Hi, my name is Alusen Barry. Welcome to this lesson on the differentiation of implicit functions. We started off solving the first example, this one. We were short of space, so we are going to just round that off and then we solve the second example, which is a past question here, this Roman one. Let's just scroll down a bit. We finish that off and then we can continue with our work. Okay, so we were rounding this off. So we said after dividing both sides by 3y squared minus 3x, we have the dy dx then becomes 3y squared minus 3x. Okay, so this is our derivative for differentiating that implicit function. Okay, now let's go on and solve the second example. Here we are asked to differentiate the function um, x squared. So we are given x squared minus 3xy plus 6y squared all equal to 15. Okay, we are asked to differentiate. Right, so we say solution. So our first step, we differentiate term by term. DIFF for differentiate term by term. Okay, we differentiate term by term. So now to differentiate this term by term, let's go on and do this. So the derivative of x squared will be 2x. Okay, to differentiate this, remember this is a product. Okay, so we hold y constant and then we differentiate with x. So we say minus 3y. The derivative of x is just 1. Okay, so we just leave it because if we multiply this by 1, it's just going to be it. Okay, the same thing. And then plus, remember it's a product rule. So we say plus, we hold, okay, so we hold now x and then we differentiate y. Okay, so this will be 3x and then we say dy dx. Okay, 3x dy dx. But remember, we're going to make a mistake here. We are going to multiply all of these by minus because there's a minus sign in front of this. Okay, so we go on and say plus. Now we have y squared here. If we differentiate y squared, we are going to get 2y dy dx. Okay, so what 2 times 6y dy dx. Remember, when we differentiate, we are going to subtract 1 from the y, right? So now we can just say this will be equal to 0 because 15 is a constant. If you differentiate a constant, you get 0, right? So we can go on and now simplify this further. So this would imply 2x minus 3y minus 3x dy dx plus 2 times 6 is 12y. Sorry about that, Steve. So this will be 12y dy dx, okay, equal to 0. So now we can collect our like terms to make dy dx. So that will be step 2. So step 2 will be make dy dx the subject of the equation. Okay, let's get some more space. So let's see how we go about that. So we say now we already have dy minus 3x dy dx here. So of course we have them already here. We just need to move these other two terms on the other side. Okay? These two terms we have to move onto the other side of the equation. Sorry, this thing is so sorry about that hold up. So we are now going to just transpose these two terms on the other side of the equation and rearrange these ones. Okay, let's take the positive one first. So we just say 12y dy dx, and the second one minus 3x dy dx should be equal to, if we transpose minus 3y to the other side, it changes its sign to plus. So this becomes 3y. And then when 2x comes over, because it's plus here, when it goes over, it changes to minus. Okay, so minus 2x. Now we can factorize dy dx out. Okay, dy dx, and then we are left inside with 12y minus 3x. Okay, is equal to 3y minus 2x. Right, now we can go ahead and divide both sides by 12y minus 3x, both sides, this side again, 12y minus 3x. Okay, so this cancel out. Let's get some more space here. So this implies that dy dx is equal to 3y minus 2x over 12y minus 3x. Okay, so this is our derivative by differentiating this function implicitly. Okay, all right, go ahead and we are going to solve the third example. Okay,